All right, 1.2 is still linear equations and rational equations, and we're going to go on day 3. So today we're going to recognize identities, conditional equations, and inconsistent equations, and then we're going to solve applied problems using mathematical models. So types of equations. So there's 3 different types of equations we can have. The first one is called a conditional equation, and for a conditional equation, you're going to end up with a solution for your equation. So in conditional, you would end up with like x equals some number. So it could be x equal, that's not x. It could be x equals 7, x equals -5. It doesn't matter, but you get x equals a number, okay? You could have one answer, or you could have multiple answers, but those are considered conditional equations. The second one is considered an identity. And remember, identity is like identical. So when you solve it, you're going to end up with something weird. You're going to end up with like 7 equals 7. Or 3x equals 3x. Or you might even notice at one point you might have like, use some different. So -5x plus 7 equals -5x plus 7. So what it is you're going to end up with a true statement. Both sides are going to be identical. Exactly the same. Therefore, your solution would be either all real numbers, or they might say infinitely many solutions, okay? So, but anyway, when you get that, when they're equal, if it's true, then it's an identity and the solution is all real numbers. And then the third type of equation is an inconsistent equation. These are the ones for which you end up with something weird, but it's not true. So you might end up with like -5 equals 4. That's not true, therefore it's an inconsistent equation. Now be careful, because if you get 5x equals 4x, that's not an inconsistent equation, because you could still solve here. And so you would get x equals, and that cancels, but it's a 0 then. So this right here is actually a conditional equation. So it's only going to work when you get a number is equal to a different number to be inconsistent. All right, so example 1 says solve and identify which type of equation this is. So we're going to solve this. When I look at this, I can't do anything on the left side, but on the right side there I can distribute. So I'm going to bring down the 4x minus 7 on the left. I'm going to distribute on the right. So 4 times x is 4x, and then 4 times -1 is -4, and then just bring down your plus 3. Still can't do anything on the left side, but I can combine like terms on the right side. So -4 plus 3 is a -1. And now we're just going to solve. So if I try to get my x's together, I would subtract the 4x, but they're going to cancel here, so we get -7 equals, cancels there, we get -1. We don't have any x, so we can't solve this. So at this point, you need to ask yourself, is this true? Is -7 equal to -1? No, it's not. It's false. Therefore, it's a no solution. I forgot to put that on the previous slide. It's a no solution, and because it's false, it's inconsistent. All right, example 2 wants to solve and identify which type of equation this is. All right, so we're going to solve this equation. Can't do anything here on the left, so I'm going to bring it down. But on the right, I can distribute this distribute that positive 9 to the parentheses. So 9 times x is 9x, 9 times 1 is 9, and bring down your minus 2x. I can still work on the right, so I'm just going to do that. Combine like terms, 9x minus 2x is 7x, and you can bring down your plus 9. And I'm going to go ahead and get my x's together. So I'm going to subtract that 7x over to the other side. And when I do that, it cancels, but I get 9 equals, and it cancels on this side, so I get 9. Now, my x is gone, so we ask ourselves, is this true or false? Is 9 equal to 9? It's true. Therefore, my solution is all real numbers, or we could say infinitely many solutions, and my equation is an identity, because they are identical. Identity. All right. Now you could have, at this point right here, I noticed that they were the same on both sides. You could have stopped there, okay? And you might not get 9 equals 9. What if I moved the 9 first? If I'd have moved the 9 first, I'd have ended up with 7x equals 7x. Still true. Still all real numbers. Still an identity. All right, so in this example, I think it should be example 3, I'm sorry. It says solving applied problems using mathematical models. So it says persons with a low sense of humor have higher levels of depression in response to negative life events than those with a high sense of humor. This can be modeled by the formula D is equal to 10 over 9x plus 53 over 9. In this formula, x represents the intensity of a negative life event, and D is the average level of depression in response to that event. If the low humor group averages a level of depression of 10 in response to a negative life event, what is the intensity of the event? Okay, so the next slide, if you printed out the slides, is blank, so you have room to work. I'm just going to try to work in the little space that they have here. All right, so they told us that we've got this equation. So let's go back over with the variables. What is the D? Well, D is the average level of depression. So D is depression. Makes sense. And what is X? Well, X is the intensity of a negative life event. All right, so what are we after? It says if the low humor group average a level of depression of 10, so that's D. In response to a negative life event, what is the intensity of the event? So we're looking for X. And I'm actually not going to be able to write it on this one, so I'm going to have to go to the next one. All right, so we know that D is equal to, I'm going to try to do some of it here because I'm not going to remember this problem. All right, so we know that D is 10. So we have 10, maybe I can do it if I do it from the other side. 10 equals this equation. And we want to solve for X. So we have fractions. So let's go ahead and let's get our least common denominator. So first thing, if I want to make the 10 a fraction, it's going to be over 1, but you don't have to. And see, 9 is 3 times 3, and then we have 9, which is 3 times 3. So our least common denominator has to have a 3 and a 3 for this one. Now, it's not going to have the 10, because remember, the 10 would be over 1, so 10 is actually a numerator. So I need the 2 3's for the first one, and then the second one, I need 2 3's. I already have it. Now, I don't have to worry about looking for restrictions because there's no X in that least common denominator. So we're going to multiply all of these terms by 3 times 3. All right, so for the first one, we don't have anything to cancel out. So we're just going to get that 3 times 3 on the outside times the 10 on the inside equals. The second fraction, the 2 3's are going to cancel. And so we're just left with the 10x on the inside. There's nothing on the outside. And then it's a plus. And the third fraction, we're going to cancel out the 2 3's. There's nothing left on the outside, but we still have the 53 on the inside. And now we can just solve this. So over on the left, I got 3 times 3, which is 9, times 10, which is 90, equals, can't do anything on the right side. Then we could subtract our 53. And we get 37, yes, equals 10x. Let's see, I'm going to erase this over here now. If you didn't get it, you better back up the video and grab it. And so we have, I'm rewriting it, we have 37 equals 10x. So we divide by 10, and we get x is equal to 37 divided by 10, or since it's a word problem, we can go ahead and divide that out, and so I believe it is 3.7. So it says, what is the intensity of the event? So now we need to write our answer in a complete sentence. So let's see. It says if the low humor group averages a level of depression of 10 in response to a negative life event, what is the intensity of that event? So for a level of depression of 10, the intensity is 3.7. All right, and that is the end of day 3 and the end of lesson 1.2.